Thanks, Andy, for the introduction. Welcome to our session on driving 6G research priorities. I'm Eric Berger, the Technical Program Director of the NextG Alliance and Research Professor of Computer Science at Georgetown University. I am joined today by senior academic leaders from 3 of the NextG Alliance's academic members. Dr. Tommaso Melodia from Northeastern University, where he is the William Lincoln Smith Professor of ECE and is the founding director of the Institute for the Wireless Internet of Things and the Director of Research for the NSF's Power Project Office. Dr. Jeff Reed from Virginia Tech, where he is the Willis G. Worcester Professor of ECE and is the founding director of Wireless at VT and CTO of the Commonwealth Cyber Initiative. And Dr. Nick Blainman from the University of Notre Dame, where he is Professor of Electrical Engineering, founding director of the Wireless Institute in the College of Engineering, and the director of SpectrumX, a newly awarded NSF Spectrum Innovation Center. More details on our backgrounds are at the roadmap.nextgalliance.org webpage. First, I would like to direct a question to Jeff. Could you discuss what you see as inhibitors to advancing next generation wireless technology?
Well, there's several issues that should be dealt with. First, security, especially with ensuring the validity of the supply chain. If countries cannot be trusted, it could mean a splintering of standards. Hence, there is a risk of losing economies of scale. Not to mention the human rights and other societal ills that could come from splintered networks. Second, understanding the new use cases. Ultra low power devices for tagging and tracking is an example of a new use case that can open new applications and requires new technology. Third, the need for spectrum sharing technology and regulatory reform. It has to happen because there's so many legacy systems operating in prime bands today that cannot and perhaps should not be relocated to make way for 6G. Nevertheless, we should use as much of the spectrum resources as we can. Fourth, disaggregation of the network is going to be key, and we'll see how well it works with O-RAN deployments. I'm sure we will learn lessons applicable to future standards.
Yeah, that certainly will be interesting. Tommaso, how can we highlight the need for strong and ambitious national programs that can only be executed by academia and industry, working with the government to achieve 6G priorities?
Thanks, Eric. I cannot emphasize enough the importance of this, right? Leadership in 6G requires new, bold ideas, and there is no lack of them in the academic community and in industry. But also it requires a continuum from basic research to use-inspired research to capabilities to prototype and go to market. And if you miss any of these elements, you fall behind. And that's in part what has happened to our US wireless ecosystem in the past few years. We also need to train talent to work and innovate in these areas. And this means training researchers and developing effective workforce development programs. In the past, you needed radio or wireless engineers focused on very specific, often hardware-centric aspects, while today you need sophisticated wireless systems engineers that can navigate radio, computing, software engineering, and AI. And without academic research, the training component does not happen. So you need a strong ecosystem, and this ecosystem is competing for talent with other ecosystems. And to create these strong ecosystems, you also need a set of bold, ambitious, focused research programs that are coordinated across agencies of the federal government that involve industry, not as an afterthought, but as an integral part of the research enterprise, and in setting priorities, but also in piloting new technologies. You also need to communicate to the general public, right? What's more exciting than providing connectivity worldwide through 6G satellites? For example, in our wireless ecosystem, technology that is developed within the DoD ecosystem, for example, through the many very creative small businesses that participate in SBIR programs throughout the nation, often working with academia on ideas developed through NSF funding. All this interesting work rarely makes it into the commercial wireless space. And there's companies that do very cool stuff. So we need new programs and center-level initiatives designed around innovative mechanisms to align the incentives of academic researchers, industry, and small businesses to accomplish big goals.
Yeah, Jeff, do you have anything to add?
Yes, companies are not as willing to take R&D risk as they were 20 plus years ago. Short-term balance sheet goals tend to get in the way with incurring risk. Pooling risk is one strategy to manage risk. And governments can pool the risk by sponsoring R&D programs in academia, federal research labs, and industrial research labs. However, these entities are disconnected to a great extent from industry needs. One reason Virginia Tech has been participating with the NextG Alliance is that the Alliance has a developed vision and consensus for U.S. research priorities.
Yeah. So Nick, how does the vision for 6G by the end of the decade change our approach to research, pre-commercial test platforms, and transfer to industry?
There's really a call to action here for the US industry and academia to work more collaboratively, as Tommaso and Jeff have mentioned. But we need to align our roadmaps and incentives, and we need to identify adequate government support for these initiatives. The US has done a pretty effective job on this in the semiconductor research, pre-competitive research through the Semiconductor Research Corporation, or SRC. And there's been progress in the National Spectrum Consortium as well, in closer to our space. We need to find better mechanisms and more funding to connect basic research in academia with more applied research and development in the commercial wireless industry. NSF's power platforms and the new RINGS program show some promise in this direction, and the new NSF Technology Directorate should help as well. Some of our best experiences in the ND Wireless Institute have involved collaborative research with companies around a shared system model or prototyping or testing platform, where the industry researchers and faculty have been mentoring the students together. We've generated intellectual property through this process, but the industry partners have been best suited to take our ideas to the standards bodies and to pursue the patent protection that we want. Without such collaborative approaches, I worry that we will continue to be too fragmented by self-interests in the US to remain competitive globally.
Yeah, I can see that. Jeff, Nick mentioned the National Spectrum Consortium. There's been a lot of buzz around the DoD's 5G test beds and their early trials of commercial 5G systems. One of the DoD's goals is to achieve communication superiority in 5G and beyond. Can they achieve that with 6G? And how is that DoD superiority relevant to the North American private sector?
Well, North America needs a strong commercial ecosystem. Manufacturing of devices, application development, IP development, network services. So far, DoD R&D efforts for 5G and beyond technologies have focused on base modernization. It's a useful endeavor. However, this R&D effort if it is intended to jumpstart our wireless ecosystem, it's going to have to go beyond just off-the-shelf components to implement new DoD applications. There needs to be a strong dose of creative risk-taking in developing the IP, the manufacturing capability, and the applications. And yes, we should expect to see some failures when taking risks. We're not going to improve our position in the world without taking risk. Bottom line is you can't have a strong military capability without having a strong ecosystem to support it.
Yeah, well, actually, and I guess to Nick and Jeff, along the lines of superiority is the concept of peaceful coexistence. As we have seen in several bands, the public policy debate has been anything but peaceful. Here I am thinking of the recent FCC FAA fracas. Can the two of you talk about what research is going on today and what needs to be done to move the North American wireless ecosystem forward?
Thanks, Eric. So during my 20 years on the faculty at Notre Dame, I've seen an awful lot of politicking and competitive lobbying and media blitzes about radio spectrum issues. I see academia, particularly interdisciplinary teams with expertise in technology, economics, and policy, as a good venue for distilling these issues and explaining them to the public, so we can figure out what problems need to be pursued from a research point of view. In fact, the TV white spaces issue some years ago is what inspired me to create the Wireless Institute in our College of Engineering and recruit faculty with technology expertise, policy awareness, and an interest in contributing to the public in this way, public good in this way. There was research done on spectrum sharing between radar altimeters and cellular systems, but it seems to have been buried. So we need to incentivize more citizen scientists to contribute to the public policy debate and ideally make it more objective and productive.
Over the past few years, we've seen a rising capability in test beds, including those at national labs and the NSF Power Program, DoD bases, and the Virginia Commonwealth Cyber Initiative. While these efforts are excellent, what is missing is large-scale test beds on operational networks. For instance, AI is viewed by the NextG Alliance and others as a key enabler behind 6G. AI requires a lot of data to train for lots of different situations. Once AI makes the decisions, those decisions impact the performance and evolution of future network changes. Hence, we need real-time test beds that we can experiment with AI without this performance data. How will carriers know that AI is worth the money? And testing is also critical for ensuring reliability. And with AI, that testing becomes even more difficult. AI opens up new threat surfaces that we need to test for.
Yeah, it sounds like there's a lot of work there. And as the NextG Alliance is this alliance of academia and industry and government, I was wondering, Tommaso, what resources does academia have for industry? In particular, as Jeff mentioned, testing, what testing platforms do we have today, and what will we need for 6G?
Right. So I have had the privilege to be involved as Director of Research in the National Science Foundation's Platforms for Advanced Wireless Research, or PAWR, or POWER, since the beginning. So POWER, in a nutshell, is trying to build a fabric of testbeds for advanced wireless research in the North American territory. And POWER is trying to do a few things for the first time in this area. First, it's funded by the NSF through $50 million of investment, but also by a large consortium of industry players that have matched the NSF contribution with in-kind and other contributions. And second, it's been based on creating coalitions of academic researchers, but also industry and the local communities where the testbeds are deployed. So POWER today has created 4 testbeds that can provide, I think, incredible resources to the general US wireless ecosystem. Powder Renew is a softwareized cellular network deployed in Salt Lake City and based on a cloud-native architecture and programmable massive MIMO base stations. And we have Cosmos deployed in Manhattan, which is also a programmable architecture with millimeter wave and programmable optical backhauls. And we have AirPow in Raleigh, North Carolina, which is focused on the intersection between wireless and drones or unmanned aerial systems. And then ERA in Ames, Iowa, focused on agricultural IoT and broadband wireless. And last, we have also Colosseum, the world's largest simulator of wireless systems, which we host and run at Northeastern. It combines in a single instrument the realism of emulator with hardware in the loop, the scale of network simulators, and the flexibility of the cloud, enabling unique research in O-RAN, spectrum sharing, and AI in wireless. So today, the suite of Power platforms provides a glance into the future with the only publicly available testbeds that enable experimentation in Open RAN, spectrum sharing, with drones, And I think these are all key foundational technologies in our pathway towards 6G. So I need to do more to get to 6G, and what Jeff was mentioning in terms of operational testbeds, that's extremely important. But I think we can also build on a solid basis that was developed in the past few years. And I invite you all to take a look at the POWER program and its testbeds.
Yeah, that is a great program. And Nick, another national academic resource for the nation is Spectrum X. Can you describe the role that Spectrum X plays in the North American research ecosystem?
Sure, I'm happy to. So Spectrum X was initiated by a 5-year, $25 million center grant from the National Science Foundation in the US, and it's the world's largest academic hub. And the goal is to bring together all the radio spectrum stakeholders so that they can innovate and collaborate and contribute to maximizing the social welfare of this precious resource of the radio spectrum. So the intent of Spectrum X and the Spectrum Innovation Center program at NSF is to facilitate large-scale, integrative, and collaborative research that fills critical gaps for enabling more flexible spectrum access and coexistence across disparate use cases, from telecom to scientific use, environmental sensing and radio astronomy, military use, and so on. So one of the main objectives of Spectrum X is to create interfaces to other hubs in the spectrum ecosystem, the NextG Alliance being one of them, so that we can collaborate across the ecosystem. Spectrum X is already a large and diverse and interdisciplinary group. It includes 41 investigators from 27 universities, backgrounds in electrical engineering, computer science, aerospace, astronomy, geoscience, economics, policy, and workforce development. I want to echo a lot of Tommaso's comments from earlier that there's a significant opportunity to come up with creative programs to develop the workforce in technology, but also in technology and policy. And that's one of the important areas in Spectrum X as well. So Spectrum X has prioritized 6 flagship research projects that we think can help promote coexistence and sharing and more efficient use of spectrum. It's also putting together pretty compelling education and workforce development programs. It's got a significant emphasis on broadening participation of underrepresented groups, collaboration with industry and government agencies, and also policy outreach. So I'll stop there, but there's much more information available on our website, including ways for students, faculty, and industry and government collaborators to get involved.
Yeah, thanks. That sounds like a lot of good stuff, and looking forward to seeing how that goes now that it's started up.
It's keeping me busy.
That's right. Tommaso, North America is coming back from our leadership in 4G. In the decades since 4G, what international best practices should we adopt, and which bad practices should we avoid?
Well, that's a tough question. So I think for example, the European research model attempts by design to create bridges between academia and industry, right? And that's great, but because of how it is structured, it tends sometimes to be less innovative than it should be, often resulting in subsidies for industry and siloed research in academia. At least this is the general perception. In the US, I believe we also have too many silos between basic research and applied research, and difficulties in moving innovative technologies from proof of concept to market, the famous valley of death. And also sometimes too much cultural emphasis on what is new as compared to what is needed for society to advance. So I think these are some of the areas that I would highlight.
Nick, do you have any thoughts?
Yeah, I can add a few. I think we need to do a better job attracting domestic students to advanced studies in this field. I mean, most of the high tech isn't taught in the undergraduate curriculum, say in electrical engineering. We tend to introduce most of it in the graduate programs. We also need to open our doors to international students again. And in kind of echoing on what I said with regard to Spectrum X, I think there's significant growth opportunities among underrepresented minorities if we can raise awareness and create more diverse and inclusive working environments in which they can feel welcome and thrive. The other thing I might add is that in addition to pushing forward, continuing to evolve 5G and looking ahead to 6G, the technologies themselves, I think we can be more proactive about how the growth of those technologies and the applications of those technologies might impact some other spectrum-dependent operations. And so we might be able to find some pretty challenging problems to explore coexistence and innovation in other areas as the cellular system continues to need more spectrum. And I think that can be a very important innovation mechanism in the US as well.
Yeah, Jeff, do we need a strong and ambitious national program? I mean, can industry do it alone in their design shops, or can academia do it alone in their laboratories? And I think we're kind of getting a hint there, but also what should the government's role be?
Well, one area that we need an ambitious national program in is educating the workforce and advanced wireless systems. 5G is very different than previous wireless standards, and there's simply not enough people in the US that know the subject. This means that our training and our research initiatives need to be focused on both retraining people in industry and in educating new engineering grads on advanced wireless topics, with, of course, a strong dose of how real systems work. We have faced this hiring issue at Virginia Tech, and we've had to look internationally for experts in 5G. We must educate more engineers on advanced wireless systems. Without trained people, we can't begin to compete internationally.
Yeah, Nick, do you have any follow-up? I mean, you did mention the Semiconductor Research Corporation earlier.
Yeah, absolutely. I think getting all hands on deck, sharing visions and aligning roadmaps is going to be key here. The Next G Alliance and its roadmap to 6G are great steps in this direction that academia and industry is already rallying behind. As I said earlier, I think the models like the Semiconductor Research Corporation and the National Spectrum Consortium are reference points in terms of large-scale government support for industry university collaborative research. But my sense is that we have more work to do to achieve something similar for this 6G initiative.
Yeah, Tommaso?
Yeah, I completely agree. I mean, we need to train engineers with a systems mentality to be competitive. And the best way to do that is through ambitious research programs and through experiential education.
Yeah, that's great. And I do want to thank all of you. We're just about out of time. Hopefully this helps people understand a lot of the direction that the Next G Alliance is setting forth on, and sort of the whys, the wise people we have here, and the whys of getting not just industry together, not just industry and academia, but there are clear roles for all three. So I do want to thank all of you for your participation today. As noted earlier today, the roadmap to 6G outlines a lot of research and development that needs to happen over the next 10 years. I am looking forward to your participation in flexing out the roadmap. So now at this time, it is my pleasure to introduce Mr. Mike Naraki of Addis and his panel, the Next G Alliance, the Year Ahead.